Good morning. Today we're going to be talking about an introduction into functions. Specifically, we're going to look at relations and how they are related to a function. A relation is absolutely any set of input and output that correspond to one another. It does not matter what the inputs are or what they go to. A function is a special type of relation where your input can go to only one output. Now here's my example. Your inputs, this is going to commonly be denoted as x, and your outputs, again, normally y. Your inputs can be any number. I'm just choosing a couple randomly. All right. A relation is absolutely any type of input and output. This is a relation. To be a function, your input can only go to one output. So for example, I can have -3 goes to 18, 7 goes to 1, 0 goes to -4. That is a function. I can also have something like 3 goes to, or -3 goes to 1, 0 goes to 1, and 7 goes to 1. All of my inputs are going to the same output. That is perfectly fine because each input only goes to one number. What I cannot have is -3 goes to -4 and 1. This is not a function. You can only have an input going to exactly one output. So let's start the notes. For 1a, is the relation a function? I'm going to look at my x values, my inputs. I have -1, 0, and +1. These are all different numbers, therefore I know this has to be a function. For 1b, if I look at my inputs, I got -1, +1, and then +1 again. Since you see +1 twice, it should throw up a red flag. The reason is you have an input listed 2 different times. The next thing you need to do is check the output. The first +1 goes to -1, and the second one goes to +1. These are 2 different outputs. Therefore, this is not a function. Really quickly, I want to change this relation. Instead of having what is shown, we're going to have -1, 0, 1, -1, and I'm going to change the last one to be -1, 0. Now, if you notice this one, I do have -1 twice, but when I check the output, I have 0 for both -1s. This just means my set has -1, 0 as a coordinate with multiplicity of 2. This purple set would still be a function. I'm pointing that out because you might see that as a quiz or a test question. I'm not going to guarantee it, but I figure you should know. All right, determine whether each relation is a function. I encourage you to pause the video, try these two, and then play it to see the answer. For function A, I have 1, 2, 3, 4 as my domain, the inputs, therefore it has to be a function. For B, I have 6, 6, 8, 9, I have 6 twice. Check your y value, 1 and 2, that is different numbers. Therefore, it is not a function. Now let's look at this in a different way. Let's look at tables and this bubble map. I'm going to check my x values, my inputs. I notice they are all different numbers. It has to be a function. For the bubble map in B, check your X column. They are all different numbers. The next thing you need to check is these arrows. 3 goes to 10, only one value. 2 only goes to one value. 1 goes to one value. 0, negative 1, 2. They all only have one output, therefore this is a function. I do want to point out once again, the output 2 has 2 different arrows going to it. That is perfectly fine. It is only an issue if I would have had negative 1 goes to 4 and 2. This is what we do not want. All right. C, look at my row of X values. They're all different numbers. It is a function. Whenever I get to D, I notice I have negative 2 twice. When I look at my outputs, they are different numbers. Therefore, this is not a function. That page is done. Let's move to the second and last page of the day. All right, we want to determine if x plus 3y squared equals 1 is a function. You are allowed to use the testing version of Desmos in this course. The reason I say the testing version is because if you use the regular version, it could give you a wrong answer. And also, if you take a future math course, you're not allowed to use the regular version. I'm going to do a couple of these coordinates by hand, and then I'll show you how to use Desmos. I want to convert this into solving for y. So I have x plus 3y squared is equal to 1. The first thing I want to do is subtract the x from both sides. So I have 3y squared is equal to negative x plus 1. There, to show you what I did. The next thing I want to do is divide by 3. And this gets me y squared is equal to negative x over 3 plus 1/3. Lastly, to solve for y, I need to take the square root. Make sure it is absolutely imperative when you take the square root to solve for y squared, I need to add in a plus or minus sign in front of my radical on the right. So I have negative x over 3 plus 1/3. There is my function. I can graph it. All right, to fill in my table, I'm going to plug in values for x. I'm going to choose the ones to make it a little bit easier, so let's start at negative 3. If I plug in negative 3, I have plus minus the square root of negative, plugging in my x, negative 3, over 3, plus 1/3. This is equal to 3 over 3, 1 plus 1/3, plus minus square root of 4/3. That is as simple as I can get it. Well, I do know this is 1 1/3, so it's a little bit more than 1, plus minus a little bit more than 1. So, about here and about there. Let's try 1. Whenever I do 1, I'm going to have plus minus the square root of negative, plug in my 1, over 3, plus 1/3. This is negative 1/3 plus 1/3, 0. The square root of 0 is 0. I have plus and minus 0. All right. Let's do one more, and I'm going to choose 3. This is plus minus square root of negative, plug in my 3, over 3 plus 1/3. This is equal to plus minus the square root of negative 2/3. This is an irrational number, imaginary number rather. Because this is imaginary, it is not going to show up on my graph. You cannot take the square root of a negative number. All right, let me show you how to use Desmos to get the rest of the coordinates and the graph. So, go to testing version of Desmos, North Carolina version, that is also important. Because this is an ellipse, it will work on this function just to type it in the way it is written. So x plus 3y squared equals 1. If the graph did not show up, what you do is erase the equal sign, put minus and parenthesis, equals 0. Actually, I told you wrong right there because I already have y in the value. To solve for an equation, you put equals minus parenthesis. I'll show you what I mean now. If I wanted to do negative 4, I try to jump ahead of myself, so I do apologize. So negative 4 and for x plus 3y squared equals 1. That does not work the way it is written. So I'm going to put minus parenthesis. The other thing you have to keep in mind, you cannot have any other variable besides x. So I am going to place the y with x. Where it is equal to 0 is my answer. So at negative 4 is going to be 1.29 and negative 1.29. And to show you graphically, if I plug in x equals negative 4, there's the two values. All right. I don't know why that's not letting me add a slider, so I'll just do it a little bit harder way. I'm going to make my function as above, but I'm going to just be changing the x values. So negative 2 plus 3. Again, you can put x if you want to solve it algebraically or graphically. Typing on an iPad is not as easy as it is a computer. Equals 1. Again, instead of equal, put minus parenthesis. I'm trying to hammer that into your head because you can use this all year to solve for a value. Negative 1 and 1. Negative and positive 0.8165. Plus minus 0.577 approximately. 2 and 4 are both imaginary, so do not exist. Okay. Plotting these points. I get this graph, which of course you could see on the actual graphing calculator. The reason why I'm writing it on paper, if I was to just show you the graph and not give you any more data and say, is this a function? Your answer should very quickly be no, because according to the vertical line test, which is simply identifying an input and seeing what output it has, you can pick any input on the left side of one, and it has 2 different outputs, therefore this is not a function. So you can try this through the 3 examples. It shows you how it works, and you have these to try for yourself. Pause it, write if they're either a function or not a function, and then play the video to see the answer. That's a function. This is not a function. This is not a function. The velocity in time is a function, and the position in time is a function. All right, we are finished for the lesson. I hope you have a great rest of your day.